everyone, and welcome back to section 3.5. In this video, we're going to be talking about functions. Now, in the previous video, we talked about relations, and functions are a very particular kind of relation. So, a function is a relation in which every member of the domain appears in exactly one ordered pair. What that means is you will never see the same x value more than once in the relation. And just a quick side note here that the range, the y values, can be repeated. That's okay, but we don't want to repeat the x values. Okay, so here we have two relations, and we want to decide if either of these two relations are functions. So let's look at the first one, R1. For domain values, we have 1, -2, 3, 2, 3, and 1. So you see that we repeat the x values 1 and 3, which means this is not a function. And for relation 2, let's see, we have -1, we have 14, 3, and we have -27. We don't see the same x value more than once, so this guy, R2, is an example of a function. So relations are sets of ordered pairs. That means functions are sets of ordered pairs, but we generally don't discuss them that way. We most often think of them as some kind of assignment or rule that is being performed on the x coordinate to get the y coordinates. So for example, if we have 1, 3 as a member of a relation R, we can think of R taking the value 1 and assigning the number 3 to it. So it's this idea of assigning or viewing the function as something that transforms one of the coordinates is what we want to shoot for. Alright, so suppose you're sitting in class and your professor assigns one homework set. So we have the student, we have the homework set, and the student is assigned one homework set. So that's an example of a relation, right? Every student in the class gets the same homework set. So student 1 gets a homework set, student 2 gets the homework set, and so on. Every single member of the domain, the student, is assigned exactly one member of the range, which is the homework set. Now, in this example, all of the students would be assigned to the same member of the range, but that's okay because we're allowed to repeat y values. Okay, so in viewing a function as an ordered pair, we have an x coordinate and a y coordinate, and what we want to work our way towards is viewing x as an input, so something that you feed in to the function, and you get out a value. So the first coordinate should be thought of as an input for an action, and the second coordinate should be thought of as the results. So here's an example. We want to determine if this relation here is a function. So to NBC, I am assigning 3 shows, namely these are 3 shows that appear on the network. And same to HGTV, Property Brothers, House Hunters, Love It or List It. And for HBO as well, Game of Thrones, True Detective, and Sesame Street. So the question is this a function? And an easy way to tell whether something is or isn't a function when using these arrows to illustrate the relation is that I have more than one arrow coming out of the same item. So I have more than one arrow coming out of NBC, HGTV, and HBO. So this is not a function. Alright, now at this point in the video, I'm obligated to issue a spoiler warning. If you're a fan of RuPaul's Drag Race, this next example talks about the winners from the first 8 seasons, and my wife insisted that I include this spoiler warning in the video, so there you have it. Okay, so for this example, we have, for the first 8 seasons of RuPaul's Drag Race, the winners of each of the seasons. So the arrow is going to the contestant that won each of the seasons. And we want to know if this relation is a function. We can see here that each of the seasons only has one arrow coming out of it. There aren't any seasons that have multiple winners. So, yeah, this relation here is a function. All right, maybe for something that feels a little bit more mathematical. Here we have some equations, and we want to determine whether the relations that are defined by these equations are functions. What we're going to do is look at the y values and see if for a particular value of y, there is more than one x value associated to it. So for letter A, what I'm going to do is solve for y. And here I just want to make sure that if I'm inputting an x value, I'm not going to get more than one output. So if I put in a number for x, then I'm never going to get more than one answer when I enter it into this equation, which would make this first example a function. But if we look at the second example, so what we're going to do here is solve for y again, or at least get y on one side of the equation by itself. Now, if I pick a value of x, let's just say, for example, x equals 0, then I would get y squared equals 4 minus 0, or y squared equals 4. So y is a number that when squared gives me 4. But we know that there's two possibilities here. Either y is equal to 2 or y is equal to negative 2. So the ordered pairs 0, 2 and 0, negative 2 both satisfy the equation, which means that for every x value I put in, I have exactly 2 y values that go with it. So this guy is not a function. All right, so let's go over some notation for functions. The most common name that we use for function is just a generic lowercase f. But there are a few other choices that we'll see a lot, like capital F, lowercase g, capital G, lowercase h, capital H. Really, you can name the function anything you like, so long as you're not confusing your inputs and your outputs. So x being the input, y being the output, we need some way of representing the fact that y is a result of performing f on x. And we write that with f parentheses x. And how do we read that? It's read as f of x. So defining a function usually amounts to doing this, writing y equals f of x. And this says, take x, we perform f, and we get y as an output. So at this point, it probably seems like we're kind of massaging a lot of hot air. So let's look at what this is going to mean for us in a more practical sense. It's really a convenient way of denoting when we have a y value, what x value it comes from. So to evaluate a function means to replace the x in the function with an actual number. So f of 3 means I'm replacing every x that I see with a 3. And so f of 3 equals 4. All right, let's try it again. So this time the x is going to be a -9. When we replace x with a -9, we have to be careful about our signs. So we'll have 3 times -9 minus 5, and 3 times -9 gives me -27 minus 5, and I get -32. Next up we have f of m squared, which this is a little bit different because m squared is a number, but it really works pretty much the same way. So everywhere I see an x, I'm going to replace it with an m squared. And since we're thinking of m like it's a variable, there's no like terms in this expression, so I just leave it as is. All right, and how about if I plug in something like x minus 3? So everywhere I see an x, I'm going to take it, and I'm going to replace it with x minus 3. So I'm going to have 3 times x minus 3. But remember, I'm replacing x with x minus 3. So I am multiplying 3 by the entire expression x minus 3, which means I need parentheses. And we get 3x minus 14. So that's kind of the basics of how we work with functions. We're going to be seeing a lot more of them, so this is kind of just to get your feet wet with the notation and the evaluating. In the next section, we're going to be looking at graphing function and the graphs of some common functions that we'll run into.